Section 6-5, Algebra 2, we're simplifying radical expressions and adding, subtracting, multiplying, and dividing them. Okay, so in the last section, we did simplify some radicals, but they all came out to be perfect squares or perfect cubes, whatever it is we were doing. So in this case, they're not perfect squares or cubes. We are not using our calculator, and we are simply breaking them down. So the method that that I prefer is doing the factor tree, because this will work with square root, fourth root, cube root, whatever root you have. Okay, so basically you're going to ask yourself what times what is 32, and it doesn't matter which two you use because we are doing the factor tree. So we're breaking it down to the prime factors. So 32 is 8 times 4. 4 breaks down to 2 and 2. 8 breaks down to 2 and 4. And that 4 breaks down to 2 and 2. So since we are doing square root, technically there's a 2 here. We're looking for groups of 2. So there's a group of 2, and there's a group of 2. So this 2 comes out, this 2 comes out, but this 2 is by itself, so it stays inside my bracket. And the 8, this is what we did in the last section. We just take our exponent and divide by the number that's inside of our radical sign. So 8 divided by 2 is 4. So that's x to the 4th. And then I multiply these. So my final answer is 4x to the 4th, radical 2. Then we do the same thing here. So I'm going to break down the 16 to 4 times 4. And then that breaks down to 2 and 2. So all of these 2's are prime. And now I need groups of 4. And I have 4 2's. So all of those 2's can come out as a 2. And then I do the same thing here. So 24 divided by 4 is 6. So this is a to the 6th. Now I can't do 13 divided by 4, so I have to find the closest number to 13 that's less than it, that's divisible by 4. So b to the 12th is divisible by 4. So 12 divided by 4 is 3. So that's b to the 3rd. And where did that other b go? Because if this is a 12 and this is a 13, there's one more b that's left over. It stays inside of the radical. And then since this is a 4th root, I'm going to see if I have anything that follows the rule that's even, odd, and this is my only even. And since this is even, I keep it. I don't need the absolute value. Doing the same thing here. So 12 is 4 times 3. 3 is prime. And 4 is 2 times 2. So I need groups of 2. So this comes out as just a 2. This 3 stays in. The c, I divided by the 6, I divide by 2, which gives me c to the 3rd. The d, same problem as before. So the closest number that's divisible by 2, that's less than 3, is a 2. So 2 divided by 2 is a 1, and there's 1d left over. And since this is even, I'm looking to see if I have the even-odd rule, and the c follows that even-odd rule, so I need the absolute value. Then I need the 3rd root of 27, so 27 is 9 times 3, and 9 is 3 and 3. So now since this is a 3, I'm looking for groups of 3, which I have a group of 3. That goes out as a 3. There's no leftovers. 12 divided by 3 is 4, and 7 divided by 3 can't be done, but 6 divided by 3 can be done. So 6 divided by 3 is 2, and I have that one more z left over inside of my radical sign. And since this is a 3, I don't have to worry about the absolute value rule. Next is rationalizing the denominator. So all that really means is I cannot have a radical in the denominator of a fraction, so I multiply the top and the bottom by whatever my denominator is, the radical, to get rid of it. And the reason why it gets rid of it is radical 3 times radical 3 is radical 9, but the square root of 9 is 3. So that's the whole reason to get rid of it, because this gives me a number without the radical. And then on the top, I just have 5 radical 3. I cannot simplify these two because this is under the radical and this is not, so that's my final answer. I'm going to do the same thing on this one. I'm going to multiply the top and the bottom by radical 7, and the bottom gives me 7. The top gives me 4 radical 7, and I keep it. Now, since the 4x is under the radical sign, I'm multiplying the top and the bottom by radical 4x, so I got a 4x on the bottom. On the top, I have 8 radical 4x, and there's nothing, oh, wait, I'm wrong. I was going to say there's nothing that can be simplified, but yes, there is. So both the 8 and the 4 are outside of the radical, so 8 divided by 4 is 2. So on the top I have 2 radical 4x, and on the bottom I just have an x. And these x's cannot be simplified because this is under the radical and this is not. That is my final answer. Okay, so now I'm going to rationalize the denominator with a cube root. I'm just going to rewrite it so I have more room. So because of this, since this is square root, I need 2 of them. This is cube root, I need 3 of them. So I have 1 5 already. So in order to get rid of this cube, I need to multiply by 5 squared, the cube root of 5 squared. Because on the bottom, that would give me the cube root of 5 times 5 times 5, which is 125, and the cube root of that is 5. That's the reason why we're doing it. So then on the top, I just have the cube root of 25, and that's all I can do. And I got the 25 from here, 5 squared. Rewriting this one. So I'm going to multiply the top and the bottom by 4 squared, the cube root of 4 squared. So on the bottom, that gives me the cube. On the bottom, that just gives me a 4. If you wanted to do this step here, it would have been the cube root of 4 to the 3rd power, which is just 4. And then on the top, I have a 3 on the outside, the cube root of 16. And there's nothing I can simplify. That's my final answer. And then we're basically doing the same thing on this one. Okay, so I'm going to multiply by the cube root of, so I have 1 2 here, so I need to have 2 here to get 3 altogether, so 2 squared. Same thing here, I have 1x, so I need this to be x squared. So on the bottom, I'm left with just a singular of whatever's underneath my radical, so 2x. On the top, I have 5 radical, so no, 5 cube root of 4x squared. And the 4 came from here, 2 squared. Okay, so I am going to get rid of I like to have 2 separate radical signs here. Oop. Okay, so you could just start off with multiplying the top and the bottom by radical 7 if you want, or you can simplify the bottom. Either way, you're going to get the same answer. So I'm just going to multiply by radical 7 over y to the 7th. So, okay, this is a times. On the bottom, I have y to the 7th. On the top, these are both under the radical. So x to the 6th, y to the 7th, but this needs to be broken down. So don't forget there's really a 2 here. So 6 divided by 2 is 3. I notice I have an even odd rule. And then the y, if that's y to the 6th, that's again going to be a 3. So y to the 3rd. And then I have a y left over on the top. And then I have y to the 7th. And now these y's can simplify, so I get rid of that. This becomes y to the 4th. So my final answer is x to the 3rd radical y over y to the 4th. Not a lot of steps. Okay, so this one, 4th root of 16 over the 4th root of 2. So first of all, I already know that the 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. So I'm just going to call that a 2 because it's easier. On the bottom, if I have the 4th root of 2, I need to get rid of it. I need to multiply by the 4th root of something. So I need 4 2's altogether, so that's 2 to the 3rd. So on the bottom, under the radical goes away, and that just gives me a 2. On the top, it's 2 times all of this. So 2 times the 4th root of 2 to the 3rd. Those 2's cancel out. My final answer is the 4th root of 2 to the 3rd, but I might as well call it an 8. So the 4th root of 8. Okay, so again, same on this one. You could simplify first or second. It doesn't make a difference, but let's just multiply the top and the bottom by radical b to the 5th. So on the bottom, I just have a b to the 5th. On the top, I have a to the 9th and b to the 5th on the radical. That needs to be simplified. So the closest number that's divisible by 2 is an 8. So 8 divided by 2 is 4. So on the outside, I have a to the 4th with an a left over on the inside. Same thing on this one. So that's going to be b to the fourth, which simplifies to b squared, and I have a b left over on the inside, but I have b to the fifth. These can be simplified, which gives me b to the third, so I have a to the fourth radical ab over b to the third, and that's my final. So both of these were odd, so we didn't even have to think about the odd even rule. Letter D, multiply the top and the bottom by radical 3. I get 6 radical 3 over 3. 6 divided by 3 is 2, so we get 2 radical 3. Moving on. So we are multiplying here. So let's start off with one that's a square root instead of a cube root. So the rule is the same for either. We can multiply what's on the outside, and we can multiply what's on the inside, then we simplify. So 6 times 4 is 24. Under the radical, 8 times 2 is 16. The c's become c to the fourth, because remember, when we're multiplying, we add our exponents. The d's become d to the eighth, and now I need to simplify. So the square root of 16 is 4. That 4 times 24 is 96. So I have 96 on the outside. Divide this by 2, c squared. Divide this by 2, d to the fourth. That's my final answer. I could do the same thing with this cube root. So 5 divided by 3 is 15. Under the radical, so negative 12 divided by 18. I mean, I could actually multiply that out, but I know I'm just going to have to turn around and break it down, so I'm leaving it as that. The a's I'm going to simplify, though. A to the third, b to the sixth. Now I'm going to do 12 times 18 and break all that down. So that's 4 times 3, 2 and 2, 9 times 2, 3 and 3. So now I'm looking for groups of 3. So I have 1, 2, 3 threes right here, and 1, 2, 3 twos. So on the outside, 3 times 2, which is 6, and then I have to multiply by that 15. So 15 times 6 is 90. And, since that's a negative. So this was a negative 6 that came out, so that makes that a negative 90. Now, a divided by 3 is 1, so 3 divided by 3 is 1, and 6 divided by 3 is 2. So that's b squared. That's my final answer. Okay, I'm going to do one more and then move on. So 2 times 3 is 6. Underneath, we have the fourth root of, so 8 times 2 is 16. Add those up, I get x to the eighth. Add those up, I get y to the fourth. Okay, so the fourth root of 16 is 2. And 2 times 6 is 12. Then I do 8 divided by 4 is x squared. 4 divided by 4 is just y. That's my final answer. Okay, so for adding and subtracting radicals, we can only add and subtract if they are like terms, and they're like terms if they have the same thing under the radical. So we don't know yet if they're like terms. We have to break them down. So 98, so I'm going to do 98 divided by 2, which gives me 2 times 49, and the 49 is 7 and 7. So the 98 breaks down to 7 radical 2. The 32 breaks down to 8 times 4. That's a 2 and a 2. And truthfully, that's 2, 2, and 2. Okay, so I have that 2 and that 2. So those two come out as a 4, times that 2 is an 8, and I have this 2 left over. These are now like terms. 7 radical 2 minus 8 radical 2 is negative 1 radical 2, which we're just going to say negative radical 2. This 8 is 2, 2, and 2. So 1, 2 comes out, times that 4, which gives me 8 radical 2, plus the 50 is 25 times 2. And if you notice right here, 25 is a perfect square. I could just take the square root of it. You can. That's 5. 5 times 3 is 15. This radical 2 is left over. So we're going to do 15 plus 8, which gives us 23 radical 2. And let's go down to multiplying. So we sort of multiplied up here a little bit when we take something out. Now this is a FOIL. So remember, FOIL, first, outer, inner, last. First is this, so you can multiply the outsides and multiply the insides. So 4 times 3 is 12, radical 6. Outer is going to be negative, 6 times 4 is 24, radical 3. Inner is here, so 5 times 3 is positive 15, and then under the radical, we have radical 2 times radical 2, which I'm just going to leave for now as radical 4, and then I'm going to simplify it when we're done. And then here I have negative 30 radical 2. Okay, let's do some simplifying. The 6 is, I cannot change. The 3 I cannot change. This becomes a 2. So that's a 2 times that 15, which gives me 30. So basically I have 12 radical 6 minus 24 radical 3 plus 30 minus 30 radical 2. I do not have any like terms, so that is my final answer. Let's do the same thing here. First is 6 times 2, which is 12 radical 15. Outer, 6 times 4 is 24 radical 6. Inner is here, negative 10 radical 5. And last is negative 20 radical 2. So no, nothing can be simplified because all of my radicals are different. And that's really what you're looking for. Are there any radicals that are the same that I can simplify? Since there isn't, everything stays. And that is it.